So here is a sequent with three premises and a conclusion. First premise is a disjunction, either A or either B or C, so it's a disjunction with a disjunction as its right disjunct. Second premise is a conditional, if not A then not C, and the third premise is a conjunction, not A and D, and the conclusion is also a conjunction, both B and D. So we write out the premises as our assumptions at the top. Each assumption is numbered for the line on which the assumption is made. So the only numbers that ever appear over here on the left are the numbers of assumptions. This is how we track our assumptions. So this is the assumption set. These are the sentences, one per line, and this explains where they come from. That's the annotation, as we call it. So the disjunction, well, the wedge elimination rule is a two-line rule. So from the disjunction by itself, you can't prove any of its disjuncts. With the conditional, the only thing you can ever prove is its consequent, not C. But you can't prove that unless you have its antecedent, not A. And then the third premise is the one that contains the most information. It's a conjunction, both not A and D. So from it, we can get not A, and also from it we can get D. What about the conclusion? Well, the conclusion, which we'll get to somewhere down here, is itself a conjunction, both B and D. We're trying to prove it on assumptions 1, 2, and 3. So if you think about what rule will go here on the last line of the proof, probably it will be ampersand introduction, the one where we take two sentences and put them together in a conjunction. And obviously the two sentences we want are B and D. Well, D we can get right away. We can actually just take it out of the conjunction on 3. So that's 3 ampersand elimination. So we're only using one sentence to prove D. It's the sentence on line 3, so the assumption set on line 4 will be the same as the assumption set on line 3, which is in fact 3, because 3 is an assumption. So we know then that this over here will say 4, and then some other line that we don't know, ampersand introduction. So now our job is to prove B, and having proved B, we can put it together with D on the last line. So in a sense, we know how to prove the last line, and now it's this that we need to prove. Well, if we go looking for B in our premises, we find it here. It's the left disjunct of a disjunction that is itself the right disjunct of a disjunction. The left disjunct of that disjunction is A. And in 3 we have not A, the denial of the left disjunct. So if we take not A out of the conjunction, just as we did D, here we're doing 3 ampersand elimination, but taking out the left conjunct of 3, not A, again the assumption set is just 3, then 1 and 5 together entail either B or C, because this is a disjunction and this is the denial of its left disjunct. So its right disjunct must be true, and its right disjunct is either B or C. And here we write 1, 5 wedge elimination. 1 is the line number of the disjunction, 5 is the line number of the denial of its left disjunct, and the sentence we prove is the right disjunct of that disjunction. 1 rests upon itself, 5 rests upon 3, and so the assumption set is 1 and 3. Well, that gets us either B or C, but we want B, and so we need not C. And not C is here as the consequent of a conditional. So we can prove that if we have its antecedent, and we do. On line 5 we have not A, which is the antecedent of the conditional on 2. So on line 7 we can prove it's not the case that C. We have a conditional on 2, of which not C is the consequent. We have the antecedent of that conditional on line 5, so 2, 5, arrow elimination. Well, 2 rests upon 2, 5 rests upon 3, so that's 2 and 3. We've proved not C. And then 6, 7, wedge elimination. Here's a disjunction, either B or C. Here's the denial of its right disjunct. And so we get its left disjunct. 6 rests on 1 and 3, 7 rests on 2 and 3, so 8 rests on 1, 2, and 3. This is line 9, the last line of the proof, and that's 4, 8, ampersand introduction. And so we've proved both B and D on assumptions 1, 2, and 3, and that's what the last line of the proof says. The last line says, if the sentence on 1 and the sentence on 2 and the sentence on 3 are true, this sentence must be true. If you question that, well, you can trace the reasoning back. Where did this sentence come from? It came from line 4 and line 8 by ampersand introduction, a truth-preserving rule. Where did line 8 come from? From 6 and 7, wedge elimination. B is the left disjunct of 6, 7 is the denial of the right disjunct, so we get the left disjunct. Where did 7 come from? It's the consequent of the conditional in 2, and we had its antecedent in 5. So we can trace back, using the annotations, each step in which we've taken from the premises to the conclusion. If these sentences, 1, 2, and 3, are true, then every sentence that follows must also be true. The assumption set tells us which assumptions were used for proving each sentence. So both line 4 and line 5, we only used the sentence on line 3. For this one, we used the sentence on line 1 and the sentence on line 3. For this, it rested ultimately on 2 and 3. So every line of the proof corresponds to a valid sequent, and the last line of the proof corresponds to this sequent. And so that's a proof which uses ampersand elimination twice, wedge elimination, arrow elimination, another wedge elimination, and then ampersand introduction.